We will start the team presentation. I wasn't planning to start with teammate, but Team 1 did a very nice intro for us, so I think it's going to be a good start for all day. So I have with me Adam Boyke, who's going to present us what they did, but first I think we have something. Very nice intro. Yeah, I should give bonus points for that too. Yeah. So Adam, can you explain us what was your design concept and what you were planning first?
So we were planning on doing a lot of program optimization and trying to get all the robots doing their own unique tasks, so that we could have the lowest cycle time and get the most amount of parts completed and assembled.
Okay. So which station is doing what and how was it organized? Maybe the camera could show the robots and everything.
Yeah,
Can you play something for us or
The
barely?
gripper just went out. So for Robot 1, we have it as, we call it the assembly robot. So what it's doing is it's taking the chassis, it's putting it onto the fixture, it's mounting the gears, the shaft, and the top, and then it's passing that assembly over to Robot 2, which Robot 2 is placing it onto its fixture, it's mounting the screws, torquing them, and then passing it to Robot 3, which is our QC robot, doing the quality control. Then it's going to pass it to Robot 4, which Robot 4 is doing the disassembly of the bolts and passing the chassis over to the final stage, Robot 5, which is completely disassembling the rest of the chassis and placing it back into the pallets.
Okay, good. So we can see on insights over there, maybe the camera can come around. You guys could have a production rush quite late, so between 4 and 5 a.m. What happened in between?
No, we give it up to the guys that stayed late last night. They were able to have a few cycles done in the middle of the night, and that's the only reason why we have the 6 cycles completed up there. And thanks to those guys that really wanted to win the competition.
All right, can you tell us maybe why you could only get the production at 4 a.m.? So what changed with the original plan of winning the champagne bottles?
So the largest difficulty was with our Robot 1, so the assembly process. We were having a limited success rate, so we'd have maybe 1 out of 5 of the assemblies would work. So we spent most of our time just trying to optimize that program, and we were able to get it successfully completing that. And then what we did is we were probably only going to be at about 30 cycles completed by right now. And what we decided to do was go for the victory. And so we tried to speed everything up.
All in.
Yeah, we went all in. We tried to speed everything up, primarily with Robot 3, the QC check. And that didn't work out as planned, and that's why we stayed at 6 cycles.
Yeah.
So
it's still a very good plan. So if you would have some learnings to share, maybe the one thing you have learned out of all of this.
So it's it really comes down to the design, the fixturing, the process, and no, it was a great competition. I'm really happy to be a part of the Team 1.
Good. Thank you, Adam.
Yeah, thank you.
Can we run something or or do you want me to go to station 2 right now?
Robot 1 is the gripper keeps going on.
If you have just one station that you could show us, like your favorite one, I'm sure you guys have at least one that's working, right? Right? Okay, we got something over there. Hope for the best.
Make it 7.
So far, so good.
And we have a little bit of guitar.
Can we turn on Teams 1 guitar? They need some distraction. Turn on the guitar.
Too bad. All right.
That's what is holding us up.
All right. Well, thank you.
Thank you.
Ryan will be speaking for Team 2. There you go. Maybe you can present yourself. I forgot that with Adam.
Sure, Etienne. Good morning, everybody. My name is Ryan Weaver. I'm the manager of robotics at Axis New England. We are Team 2, and we think we did pretty good.
You did. It started late, but I know you did good. So maybe you can start with explaining your design concept while it runs. This one is running real time, or mostly with some little human help. That's fine. We're not looking.
So our design concept, we actually stayed pretty true to the design concept for the most part. We went with an assembly line style idea. So the idea was to break down the process on a per robot basis. So each robot would take a small chunk. Basically, we assigned robot 1 should be handling what we considered phase 1 of the assembly, which was everything from picking the base plate, placing it down, taking the this piece, what do we call this guy again?
The chassis.
The chassis, right. Chassis down, and then passing it along down to robot 2, which is going to complete phase 2 of the assembly part. So it took that, placed it on the conveyor, sent signal to robot 2 in order to index the conveyor down. We've got it so the fingertips block it, so it will walk into the conveyor, walk into the robot fingers to locate it, pick it up, place it into the jig, and then that's where we do the assertion of both gears and the shaft, as well as the top plate. So that completes the majority of the assembly process, except for the screw driving, which is handled by robot number 3. So we do screw driving, testing of the QC, removal of the screws. We send it over to robot number 4, which is now doing disassembly phase 1, and robot 5 does disassembly phase 2. So phase 1 basically consists of removing the top plate, removing both of the gears and the shaft, placing it on the conveyor, sending it down to robot number 4 on the conveyor, which will then pick and do the remainder of the disassembly process, getting ready to run robot number 5 again.
Nice. So this was your original design, and you stick to it?
Yeah, we basically didn't change anything in terms of what robot was going to be doing what, and to somewhat creating some bottlenecks. I think if we could do it over in some ways, we might have done some of the screw driving or some of the other stuff a little earlier, because most of the bottleneck did occur on the QC station, which was doing a lot of that screw driving as well. But what we were able to do, because we took advantage of that bottleneck, one of the things that we overcame in that challenge was to have 2 parts running simultaneously. So I don't know if you can see right now, but basically we're doing a QC check, and we're going to do a drop-off to this robot number 4 for disassembly while we're starting over the assembly process. So because we have that lag in the bottleneck, we can run 2 parts simultaneously.
Very good. And in fact, I think you're the only one who reached our takt time of 6 minutes. It was quite late, but I know you did 6 minutes takt time for an hour at 2 a.m., something like that.
It was quite late. Quite late. But no, it was great. We actually, for about 2-hour period, we ran a total of 10 cycles per hour, or 10 parts per hour through. So that was a pretty good time. We found that it seemed like over time the parts were kind of maybe breaking down a little bit and loosening up, so they wouldn't be repeatable. But once we got past that initial phase, it was really good.
Good. And what went wrong after that initial line? Because I know what went wrong. I don't know if you do. Because you were winning at some point if you would have kept that. But I know like the guys got greedy. And everybody thought, okay, let's speed this up.
Well, I don't know if everybody thought let's speed this up, but
someone did.
But as a collective group, I think the majority we did speed things up a bit, and so yeah, we had a rhythm going, and it's a delicate rhythm, and I think the term was used earlier in the presentation that these things can, or not presentation, but in this in the RUC, that little things have a butterfly effect in processes like this. So if we change the cycle time on one part, we end up now having robots that collide because they're trying to share space that we never intended them to share. So,
makes sense.
Excellent.
Thank you, Ryan. Very interesting.
Thanks,
and
Etienne.
good job. We'll move to station 3 now. So Oliver is presenting for station 3. Is that it? Can you present yourself first?
Hi.
Yeah, it's on.
Good morning. I'm Oliver Tan from Bross.
Speak close.
From Bross Company.
Yeah.
So, go ahead and ask me some questions, Etienne. You look good today.
Thanks, man.
Yeah, you're welcome.
So can you explain us what was your concept idea over here?
So, our concept was pretty much the same as everyone else's concept. Our plan was to have 2 assembly processes, a quality check, 2 disassembly processes using the conveyors as passing components. And that was our plan. We had most of our success in the disassembly and the quality check, but obviously the hardest processes were for assembly and inserting the shaft into the hole.
I think you still managed to do some, at least at some time we can see it over there, right?
Yeah, sometimes we
So
can.
what was the solution to your problem?
We tried to use as much Robotiq skills as possible. We did the pecking, we did the searching, linear search, things like that. Some of them were a little difficult because it wasn't exactly, I guess, perpendicular to the Z. So it was difficult to find, so we had to just try to find other ways to get that solution done.
Yeah, I know it was difficult. It's a challenge and not a walk in the park, but you still did good. Maybe you can explain us from like the organizational point of view, so management. I know there was a lot of challenge on teamwork and spreading the load across the team members. So how did you manage that?
So we obviously did your design plan phase first, and that's how we managed all our plan. We had our 2 assembly processes because we had to do a quality check at this one. And what we ended up doing was the first station inserting the base, the chassis, and the 2 gears, and then passing it on the conveyor to the second station where it picks up and assembles the shaft, the top, and the screws. After that, it will go to the quality check, pass it onto the conveyors on the right side, robot 3 and 4, or I'm sorry, 4 and 5 for disassembly.
All right. So what was the bottleneck, and what have you learned something with that lean robotics approach over there?
Yeah, we did. The bottleneck was obviously the assembly because the screwing took the longest. We did not. Our plan was to have that all optimized after we got it going, but that didn't work out, as you can see. We have most of it going right now. The quality check was running, and the disassembly was running, but we only had a few parts. I don't know how many parts we had. 14 parts, I think.
Yeah, you do some. We'll show all the results of production of every team on stage later on before the awards, so you'll see how you did quite soon.
Okay.
Thank you, Oliver.
Thank you, guys.
Now, let's move to Team 4, our Latin friends. Who will be presenting? Carlos is presenting. Can you present yourself first?
Yeah, sure. Hi, my name is Carlos. I'm coming from Spain. Coming from a company called Beta Robots, located in Barcelona.
So we can see it.
That's pretty much it.
All right, so explain us your concept first. I've seen very early on we could see that you guys had a different approach, just the way you were working on very early over there. It was nice to see, so maybe you can explain us how you proceed.
Sorry?
How you did the design, the early stage.
Yeah, in the early stage, the first thing that we try is to do the process manually in the table. That was part of the key of the design process. So what we did in the end, initially, was to have the.
Maybe you can detail that, because I found that method very interesting. You're the only one who did that, and it was very nice to see. So maybe you can explain what you did so everyone can understand that.
after a little bit of brainstorming with all the team, we decided to test a couple of alternatives by hand. Just each person would do the role of a robot, trying to simulate also the speed of the robot, especially in the screwing part, which is the most time-consuming task in the process. Yeah.
So basically, you were playing robots to know if your design was good.
Exactly.
And it took a few minutes, and you would already know like the bottlenecks of your ideas and everything like that.
Exactly.
That was a good idea.
Yes, it was.
Keep on explaining. Sorry for that
So
interruption.
we decided initially to have assembly and disassembly in the back. We discarded from the beginning the use of the conveyor. We thought it was an unnecessary complexity to the problem. So because of the reachability of the hand, of the arms, could allow to do that. Then the screw-in and non-screw-in stages will be this one. And of course, the final check here, with optionally adding the handler. But in the end, we didn't do that. So first, we moved into the task development, and then we created a full cycle to test each task. And in the end, seeing the status of the competition, so we decided to keep that cycle and improve that cycle.
Yeah, at some point you were trying to get the handle working so that you would be winning the challenge for sure.
Yes,
And
but
what happened with that?
yeah, it was really hard to achieve that task. Yeah, yeah. But we were close.
Yeah, you worked for a few hours on that, right?
Yes.
All right. Well, good job.
Thank you.
Let's move to Team 5. So Paul will be presenting us for Team 5. There you go, Paul. Present yourself.
How's it going?
Pretty good.
Hi. So I'm Paul. This is Team 5.
Speak close to your mic.
Sorry. Yeah, so we're Team 5. As you can see, we had some, fairly good success with this task. It doesn't look like much now, but 10 minutes ago it was all going. So the main application, fairly straightforward, same as everyone else. These two robots worked on the actual assembly of the parts. We broke it into two halves. So the robot would do the initial stages, putting the gears into the actual chassis. This robot was just putting the lid on, screwing the bolts, and then passing it onto the test station. Send it down. Then we had, the two different disassembly robots. Fairly good success with everything but the final stage of disassembly. That pretty much sums it up.
So you were using the conveyors.
We did have the conveyors moving at one point.
Good job.
Now, maybe not so much. Yeah, we decided to go for they're collaborative robots at the end of the day, so we thought we'd go for a symbiotic relationship of, utilizing the human intervention. That might have meant moving parts around, that might have meant tightening a few screws here and there, but...
So what have you learned out of yesterday? What would you change? I see you guys were moving from some design phase and moving one way or another.
Yeah, the only change we'd really take is, I don't know, probably, I'm not too sure to be honest. We were fairly happy with our application. We thought it would run nice and smooth. And so to be honest, we found that the main issue was tolerances in the parts and movement on the jig placements. So probably if we had a bit more of a robust setup, we'd find a bit more success in that application.
What prevented you from producing in the end? Was it just a time, like programming bottleneck?
Yes and no. We accidentally deleted a major part of our program, so that threw a big spanner in the works.
Yeah. I know. By the way, we broke a record yesterday, the Bon Entente alcohol sales, and I heard,
yeah.
Yeah, you helped a lot on that side.
I'd say a good third, you invite the British, so you know you gotta expect something.
You have to choose your fights, and I know you choose another fight. So, but you still did a very good work.
Yeah,
Congrats.
well, we tried. You know, we had to make up in some respect.
All right, great. Thanks you.
Thank you.
On to station 6. Who will be presenting for team 6? Yes, present yourself. So team 6 is our German friend who are very hardworking and working late.
Yeah, a little bit. Hello together. My name is Michael from Jugend und Künste in Germany. Yeah, it was late, really late, but we get it running. Very slow and very simple, but we get it running. We had big problems with the communication between the different robots because our first target, our first plan was that every robot should work. And so we would like to work at 5 stations all together at the same time. And we didn't get a communication, and then it became late and later, and it was today. And afterwards, I was alone.
So basically, you're running a single robot at a time, but the whole setup is being used, right?
Yeah, exactly.
Okay. So because we can see with the inside cycle counts that you guys have been running for quite a long time with different production levels, but
Yeah.
so we see that you could get production high at some point. What were you trying to do at that moment? Was it using all the robots together?
I have no idea.
You were too bad at that time, huh?
Maybe I was too drunk at this time. I don't know. So I really don't know. I can't explain to you. So we had a good hour maybe.
Yeah, because you have been running for a long time. That was good. Now the only challenge you guys didn't match was the cycle time, mostly because you're running a single robot at a time. So it's really setting up the communication that prevented you from running like in a lean way.
Yeah, that was the main problem, at least.
Was there anything to change, like on the teamwork side and how you spread the workload?
Hard question. No, the team worked good, for my opinion, but many of them was tired, and so I was alone the last time, and it was hard. And my last target was to get it running, slow, but it worked. So for me, it's fine.
Yeah. Don't worry, it's normal to be tired at 3 a.m.
Without sleeping until now.
And you still did one of the best results. You have 55 counts over there. That's halfway through our target of 100 pumps. That's a good job.
Thank you.
Now to station 7. So who's our speaker for team 7? Oh, Martin will be speaking? Yes, good. Present yourself, Martin.
Good morning, hi. So I'm Martin Buckley from ITS in Ireland. I'm the technical director, and we have had a long night. We had a great night, and we have a great team.
Yeah, I seen you were rising the team spirit with the pack of Rockstar at 4 o'clock or something like that.
Yes, but the Rockstar helps, you know. So we went Rockstar, and somebody provided coffee. So after that, we just kept going. But we have a really good cell.
Yeah, explain us your design.
Yeah, so we went and used the pallets that were provided, and we looked at all the different options, and we also did a manual assembly also, just to try and decide what was the best way to put this together. So the time constraint was a bit of an issue. The amount of people that were involved was a bit of an issue because it wasn't really a lean design. There was too many people. So we took a decision. We said we'll do this, and we went to use a pallet system. So we start with full pallets, full being 5. So for some reason there's 5, 5, 5, or there's 6 slots. So we use 5 gears. So
Part of the challenge.
part of the challenge. So for R1, is here. So you can see this one is just assembling, it's just starting. It's put the base plate on, it's looking for the chassis here. And then we use the find to
Keep on going. That's
find to mesh the gears. So this is just what it's going to do there right now, like some of the other teams have done. But this one works very well, and that the sequencing took us a long time to sequence between number 1 and number 5, which was taking 3 empty pallets to station number 1, where it was looking for 5 full ones.
Yeah. We can see that you took longer to get running, but now you have multiple robots running at the same time. So I guess that was the main challenge, to get everything working in sync.
Everything working in sync, but to be fair, that there's empty pallets at the start, you know, so that R5 is sitting waiting until the whip comes around, and then it's in sequence. So this is what's required. So here we've got Robot 2, and it's just done the seek there to put the top cap on top of the shaft. So we've also then got the seek function here for the threading. So we find it, drop it in, and then we're doing the spiral.
Good job with that.
So we used the tools given first, but it was too slow. So we then just did this as a rotation. So it's running well, and it's much faster. So we're able to do 360 degrees plus 180 in one go. So this is working well. We originally thought that we would use R3 to do some of the screw insertion, but I think you're aware we had a bit of difficulty there, so we...
Yeah.
Yeah. So R3 is just doing the quality check, doing the switch, putting up the counter, and then we go over to R4, which is running there now, and it's doing the disassembly, stage 1 of that. So it's untorquing, placing the screws into the pallet using the find function, and from there then we're replacing into the pallets, which are transferred across to station 2. That's all working.
Okay.
And then we have the final body transferred onto the belt. So we transfer the belt to a fixed pulse. So we're using 450 counter to bring it into the range of the camera. And the camera is finding the body and locating it, and that's locating it into our fixture for the final disassembly.
Okay, so you guys are using vision in the at some point too.
We've used all the tools.
Great. Say
Conveyor tracking and that.
Very nice. So we can see now you have the best cycle time, but you got it running at well, I don't see from here, but 4 or 5 a.m. basically.
Yeah, well, you know, we were here all night, so...
Was it your initial design, all this? Because this is a very complex synchronization of work between the robots.
It was our initial design. So...
And you stick to it?
We stuck with it. We didn't stick with our control protocol, really. We tried a couple of different systems to get 5 and 1 to communicate. So Leighton, Fionn and Mark put a lot of time into it, and we got it sorted. But we're really pleased. We're really pleased with the challenge, and that, we're delighted that it's running, and that we're delighted to be here holding the mic saying, great, you know. So lean on me, Robotics, I think really good.
Good, great, good job.
Okay, thank you.
Thank you, Martin. Now our last team, Team 8. Who's going to present for Team 8? Yeah, you're there. Present yourself, please.
Good morning, everyone. I'm Kevin Kerr with Hartfield Automation. I'm based out of the Texas facility, representing Team 8. Woo!
Yeah.
So our approach was a little bit different from what we had seen and heard from the other groups. With our approach, we ended up deciding that the best round was that each robot could do its own assembly and disassembly. So the 4 robots can do all the assembly and disassembly, and then the third one in the back just does the quality inspection. The quality inspection one is the one that's actually handling and doing the handshaking via Modbus to the other 4 robots to actually decide which one it needs to drop off the part to and where it's picking it up from.
So that's a very unique design, and you are the only one to do this, basically. What was the advantage of doing that, and what was the counter side of doing that thing?
Well, obviously, we wanted to get the champagne first and be the first team to finish the first part. So for our standpoint, it was easier if we could do the assembly in here because we knew exactly where the parts were going to be picked up in place for each spot instead of having to worry about transferring the different molds and things between the different robots. So we felt like it was a competitive advantage to help us get up faster.
Yeah, and also just on the like sharing the workload. I know I've seen you guys work with a sub-program. Each one of you were working on a specific task and then sharing with everyone else. How did that go?
That was one of the things that we would change the next round. I think we would focus on making a feature. When we actually did it, some of us were on the disassembly team, some of us were on the assembly team, and others were in charge of organizing all the communications and then the quality. So when we went to go combine the disassembly and the assembly programs, we kind of ran into some little modifications that needed to be made that ended up being a little more of a problem than anticipated initially. So to fix that, next time we would use features.
Well, good job.
Thanks. We'd like to let it run.
Yeah, show it.
So here you'll see this robot doing the disassembly. We have the assembly starting over here. As soon as the assembly is finished, we'll actually come over to the quality. We'll actually pick up the handle and do the quality inspection. And then this third robot back, or the first robot in the back, will actually pick up the finished part after the quality inspection.
Maybe we should focus on the Robot 5 over there. That insertion was one of your best thing, if it works that time. You've been working on that for a while, huh? Yeah, good job. So what prevented you from using the 5 robots together?
Time. Really, when we had to go
Understand that.
integrate the disassembly and assembly, it was a lot more time consuming than anticipated. So that's why that one's just not taking part in the whole process.
All right, well, good job and bravo to your team.
Thank you guys, and thank you for Robotiq for hosting.
So we'll take a break and then we'll go after that to the awards. So basically who wins both the sales and the tech challenge. So we had two challenges. I will start with the tech challenge, then Sam will come up to speak about the sales challenge. First of all, this is the insights of the team who won. So you can see over there how they managed to actually win. Ramping up all day long, getting to production quite late, and they never stop. They should also win the Motivation, Determination Awards. And this is what they made. So you can see that they keep evolving during the day, going faster and faster with less and less protective stops. So that was a good work. So here it is for all of the teams. So 7 of the 8 teams could produce. We see team who won has 60 counts. That's quite close to what we were targeting. And during the night, the competition between those 3 teams over there was quite tight. So team number 4, you guys won. Come up. So we have Mathieu, gather your team, everyone on stage. We got the salespeople too.
That's okay. Because they also won the sales challenge. Team 4 is also the winner of the sales challenge. So, all category winner, congratulations. That was the all-star team of the RUC 2017. Congrats, everyone. So we're gonna be doing the closing remark. While we're switching presentation, I just want maybe to have Etienne, if you want to come back on stage. And so Fanny, is it the sales award there? This was the sales, okay. So we're gonna get back. I just want to, before doing the closing remark, that we give a big round of applause to Fanny and Etienne, who were the two main leaders for this event. So, awesome work, awesome. I had well deserved, well deserved. I had so much praise about the quality of the event and the good times people had, and not only the good times, but also the useful time in terms of learning and going back, being having more information and more motivation to keep pushing the industry. So I think you guys did a great job, and it reached a target. Thanks. So, I think Etienne and Fanny and all the team and all of you guys put the bar really, really high. And I don't know what the RUC 2018 is going to look like. We're going to need to figure it out to have it even better. So what I want to open up with is tell you a little bit what we're going to be working on in the next year. And obviously, we're kind of opening the roadmap a little bit, and things change very quickly. So there are things that I'm telling you here that might not materialize. But anyway, just keep in mind that we're gonna keep pushing on our side as well. And we're gonna keep pushing in the same direction. So the one that we started here, so deploying more productive robot cells faster. So on the design phase, we're gonna keep improving blueprints. So it's a great thing, it's a software. We're gonna have a lot of information on how you guys are using it. Right now, what Blueprints is about is more about capturing the data of the manual process, and we're going to start there. And when this is settled, then we're going to be able to potentially move a little bit after in terms of how do we automate the thing. So giving more recommendation and maybe have some better tools for collaboration. In terms of integrate, so who here, which team used the skills during the challenge? Raise your hand. Good. So these skills, they're created by our integration coaches in collaboration with the R&D. So they come up with skills by having to support the different applications. So when they see questions come in again and again saying, hey, how can I do this with the sensor? They say we should do a skill for this. So we're going to keep doing skills. So anytime you interact with the coaches, that's good input you're giving us for what kind of skills we can be developing. Another thing we can do is right now the skills are for download on the website. So we're thinking that there could be ways to link insights and the skills to have a tighter integration. So have it remove a little bit of friction when you want to use the skills on a robot program. So that's the kind of thing we might be working on. And in terms of operate, so at this event we have a new version of the FT300. But I just want to tell you that we're going to be launching new plug-and-play components also. So these are important building blocks in the lean robotics approach. So there's going to be new plug-and-play components launched during the year. The UR caps will be improved also. The next one to be improved will be the FT300 UR cap to be released very shortly. And I mentioned it. So the skills they're useful in the integrate phase, but they are also very useful in the operate phase. And the skills will be an important piece of development for the coming year. In terms of insights, so insights, we're just launching it. I heard we sold the first one yesterday, thanks to Mark from AMC. So congrats, Mark, with a local customer. And this is really just the start. I think Insights has a lot of promise. You guys showed a great response for the product, and from here we can go a long way. I'm pretty sure. So we heard it in the user panel yesterday. One wish of all the end user on the panel was to have custom KPIs. So not only the thing that are specifically on the robot, but can I have my own information, my own alerts, my own KPI that I could track. So that's something we're going to be working on. Give you guys also some tools to help the development. So just like big software development team, they have tools to develop code. That's something we can do to help the team that have maybe a bigger fleet of robots in terms of configuration management. So once we're going to have some data after a few months, we're going to be able to see some patterns and potentially be able to do some conditional maintenance. And we're thinking, so when we talk about eliminating the waste, one waste is definitely driving around and doing support calls over the phone with very partial information. And we believe insights could be a great way to, again, improve the efficiency of communication between the partners, between the end users, between us, to do remote support and potentially also remote operations. So again, insights, I think it's great as it is today. It has value today. We can go out and use it and sell it. But I also believe there's going to be a lot of great things coming for insights in the coming year. So this year we talked a lot about the design, integrate, operate cycle. But in the book, for those who are going to read it, which I hope is going to be everybody, there's also a whole section on how to scale, how to go from 1 to 10 robot. And how you do this, well, you build your own skills and you build your robot skills. You standardize on standard building blocks. And then the first project is a little longer, but the second project is going to be much faster. So I think that's definitely a theme we're going to be exploring as our customer want to ramp up and deploy more robots. So tomorrow, I'm going to be going to Montreal to sign a memorandum of understanding with ETS. So ETS is a technical university that produces a lot of automation engineer in the province. And we're launching an industrial research chair in lean robotics. So these guys, they're going to be working on future stuff. So we can do a lot of things here today. We can do a lot of things in the factories. But there are many ways we can simplify and make robotic cells more powerful. And we keep investing in fundamental R&D. And what these guys will be doing in the next few years with the few millions they're going to get in research fund, we will find them in some of our projects, some of our products in the future. So this is it, guys. That's the end of the RUC. And yeah, Fanny tells me there are posters over there when you go out. So that big rock wall with all the round things, you can pick one. These are all posters, so pick one as you go. And it's coming to an end. And as I was saying in my opening keynote, this is the beginning of a whole new chapter. And that's a little scary for the Robotiq team because the team has worked so hard. But it's not the finish line. The RUC was not the finish line, although it really felt like this. It's really just the starting line. It's really the start of a whole new chapter, all these new products, all these new approach, and it's starting now. So hopefully we could give our partners, our customers, some momentum in that direction, and now the real work starts. So thanks everybody for being here. That's been an awesome event. I've been blown away by seeing those people working, pulling all-nighters, programming robots. I don't believe it. It's awesome commitment from the partners and the end users, and I'm thankful. All right, thanks.